So these are the atoms from layer A. They are parallel. This is layer A and this is also layer A. Then atoms of layer B comes in the voids. This is atoms of layer B. And here also then going A, B, A, again B. So what is this shape? When we join these lines, we will get a shape of hexagon. So this is called hexagonal close packing. In two dimension also there is one hexagonal close packing. Here it is also hexagonal close packing. So in 3 dimension, the second type of arrangement is called AB arrangement or hexagonal close packing. This arrangement also has the same coordination number 12. In this arrangement, after arranging first layer, there are two top void A and void B. Second layer is placed in void A and third layer is again parallel to the first layer. And so on, it is continuing like that. So we'll get A, B arrangement. Here we'll get the shape of our hexagon, so it is called a hexagonal close packing. So in 3 dimension, the actual crystal structure has 2 arrangement. One is CCP, it is also called FCC, and another one is HCP, hexagonal close pack, which is more closely packed. Both are equally close packed with coordination number 12. That is, its efficiency, packing efficiency is 74%. In both arrangement, the efficiency is 74%. That is, total space of 74% of this total space is occupied by atoms, and remaining 26% is occupied by vacant space, and it is called the void. So here we can say that all these arrangements are equally close packed. CCP is equal to FCC equal to HCP. All these arrangements are equally close packed with the coordination number 12, and the efficiency is 74%, and the vacant space, that is void, is 26%. So here we studied about 2 types of void, void A and void B. So we will see the actual shape of that voids and the amount or percentage of that voids. So void is the vacant space of between atoms in a close packed arrangement. That is a definition. It is a vacant space between atoms in a close packed arrangement. We know that, we assume that atoms have spherical shape. So when we arrange spheres, we will get a lot of vacant space in that. That vacant space are called void. Actually, there are 4 types of voids. Trigonal void is a very small void. Trigonal void. Tetrahedral void, according to their shape. Tetrahedral void, octahedral void, and cubical void. There are 4 types of void: trigonal void, tetrahedral void, octahedral void, cubical void. This is the smallest void, and this is the biggest void. Like that, the size increasing. Trigonal void, tetrahedral void, octahedral void, cubical void. But here we are studying only about 2 types of void, that is tetrahedral and the octahedral void. Tetrahedral void. You can write TV. And octahedral void. that is OV. So, after arranging atoms in first layer, we'll get a void A. This is atoms from first layer. Then when we keep the atoms of the second layer, we'll get a structure like this. When we consider this void, three-dimensionally you have to imagine, there is 3 from one layer and 1 atom from the second layer. It is in contact with the 4 atoms. Or we can say that the coordination number of this void is 4. When we join the shape of all these atoms, we'll get a shape. This is void, 1 above the plane and 3 below the plane. When we join, we'll get a shape like this. This is called tetrahedral shape. That is why this void is called the tetrahedral void. So definition for tetrahedral void is a void which is in direct contact with 4 atoms. A void which is in direct contact with 4 atoms, that is called tetrahedral void. When we join the centers of that atom, we will get a tetrahedron. So on the corners of tetrahedron, the atoms are placed. Then second one is octahedral void. This is the shape of B void. This is atoms from the first layer. Then we are placing the second layer on the void A. So this is void, octahedral void. Here 3 atoms from first layer and 3 atoms from second layer. When we join their centers, what we will get? I'll draw separately. We will get an octahedron. That is, this void is in contact with the 6 atoms. When we join the centers of this 6 atom, we will get an octahedron. That is why this void is called octahedral void. Octahedral void. So there are 2 important, there are 4 voids, but here we are discussing only 2 voids. That is tetrahedral voids and octahedral void. In tetrahedral void, a void which is formed between 4 atoms, and octahedral void is a void which is formed between 6 atoms. This void is in contact with the 4 atom and this void is in contact with the 6 atoms. So their coordination number is 6. When we join the centers of that atoms which is come in contact to direct contact with the void, we'll get a tetrahedron, and here we'll get octahedron. So that is all about the voids. Then we have to find, by using X-ray study, we know that there are 74% of the space is occupied by atom and 26% of the space is occupied by voids. So in close packed structure, close packed means there are 3 types of structure, that is CCP and which is equal to FCC and which is equal to HCP. Always remember this. All these are same: cubic close packing, face centered close packing and hexagonal close packing. Here 74% of atoms and 26% of voids. Or we can say that per atom there will be, the smallest void is tetrahedral void. 4 tetrahedral void and 8 tetrahedral void and 2 octahedral void. Note, in a unit cell per atom there will be 2 tetrahedral void and 1 octahedral void. You have to by heart this one. In close packed structures, per atom, that is the effective number of atoms, Z. Per atom, there will be 2 tetrahedral void and 1 octahedral void. So in HCC or in CCP or FCC, we already learned the value of Z. Z is 4. That is, there will be 4 atoms, 1 atom from the corners and 3 atoms from the face centers. For 4 atom, there will be 8 tetrahedral voids and 4 octahedral voids. So you have to by heart this one. In close packed structure, close packed means you have to memorize that all these are same. There may be a cubic close packing, FCC or HCP. In all this arrangement, per atom there will be 2 tetrahedral void and 1 octahedral void. So the Z, effective number of atom, we already learned in the another class. There will be 4 atom per unit cell. So per unit cell there will be 8 tetrahedral voids and 4 octahedral. Tetrahedral void is a small, so number will be more, and octahedral void is the biggest void, so number will be less. Then we'll do some problems related to this. In a crystal, A atoms forms FCC structure. In a crystal, A atoms form FCC structure. B atom occupies half of the total octahedral voids, and C atom occupies half of the total tetrahedral void. What is the formula of that crystal? What is the formula of the crystal? So once again I will say the question. In a crystal is made up of 3 atoms, 3 different atoms, A, B and C. A atom occupies FCC arrangement. Then B atoms occupies half of the total tetrahedral voids and C atom occupies half of the total octahedral void. Then what is the formula of the crystal? So for finding the formula of the crystal, we have to find the effective number of A, B and C and take the simple ratio of that atoms. So what is the effective number of A? Z of A. What is the effective number of A? So A is forming FCC structure. FCC means atoms occupy at the corners and face centers. So we can say that corners 8 into 1 by 8 plus 6 faces 6 into 1 by 2. So what effective number of A is 4. Then effective number of B occupies half of the total octahedral void. So the lattice forming atom is A. Number of A is 4. So for 4 atom there will be 4 octahedral void. So total octahedral void is 4. Then half of it. So what is the number of void? Number of atom in that void will be 2. There are 4 octahedral void for 4 atom. Per atom there will be 1. Per atom there will be 2 tetrahedral voids. So here half of the voids are occupied by B atom. So total void is 4. Half is, so the effective number is 2. Atoms in the voids are not shared by other unit cell. We have to imagine like that. We have to assume like that. Then Z of C. It is a half of total tetrahedral void. What is the number of tetrahedral void? Per atom there will be 2. So for atom there will be 8. Then half of it. Half into total tetrahedral void is 8. So its number is 4. So we got the number A is 4, B 2, C 4. On simplifying by dividing by 2, we will get A2, B, C2. So this is the formula of that crystal. So calculate what is the formula of the crystal in which A atoms forms FCC lattice, B atoms occupy half of the total tetrahedral void and C atom occupy half of total tetrahedral. You have to find the effective number of all atom and take their simple ratio. Then we will get the formula of the crystal.